Lesson 12 is angles and parallel lines. And before we get started, this lesson is pretty heavy with new vocab. So if you have a printer and you're able to print this page, I would definitely recommend it. Um, all these vocab words are going to come up pretty frequently throughout the course. So if you aren't able to print it, definitely still write them down so you have them to reflect back to. So 12.1 is congruent angles and parallel lines. So starting at the top with our first few vocab words. So a transversal is a line that intersects two other lines at different points. In the figure to the right, line L is the transversal, so this one that kind of cuts the other two lines, or it intersects the other two lines, that's the transversal. Has to be intersecting two lines or more, I guess it could be, but it definitely has to be crossing more than two, or sorry, at least two. So we wouldn't say, that like N is a transversal because it's not intersecting two or more lines. And then for the corresponding angles, those are angles that have the same relative position at two intersection points of the transversal. So we can see some corresponding angles like on the graphic on the right. So they're kind of like they have the same placement, but they're at the other intersection. So let's say, for example, angle 1 and angle 5. Those are corresponding angles because they're in that upper left kind of corner, but they're at the different intersection points. So we can say like angle 1 and angle 5. Another set could be angle 2 and angle 6 are corresponding. So angle 2 and angle 6. And then there's the other two pairs. I'm not going to write them down, but we'll just kind of point them out. So angle 4 and angle 8, since they're like the lower left corner. And then angle 3 and angle 7, they're in the lower right kind of corner of the both intersections. So those are corresponding as well. And then the next couple definitions, we're really going to have to dissect like word for word. So alternate interior angles. So think about the first one is like the word interior, that means inside. And then alternate means like kind of switching sides. And that means two different things here. So the definition though is opposite angles on the inside of the two lines that are intersected by the transversal. So anytime you see like alternate interior, the word interior should trigger your mind, okay, I'm only looking at the ones that are inside the two lines, like they're inside of kind of this whole intersection thing. And then alternate means on like kind of opposite sides. So that means on opposite sides of the transversal. So for this one, examples of alternate interior, and again, we're only looking at these angles because those are the only interior ones. Alternate could be like angle 3 and angle 5 because they're on opposite sides of the transversal. So I could say angle 3 and angle 5, and then the other pair would be still same thing inside. The other pair of alternate interior would be angle 4 and angle 6. So both inside but on opposite sides of the transversal. So angle 4 and angle 6. And then the next one is really similar, it's just kind of like exterior instead of interior. So the next one, alternate exterior angles. More exterior means outside, think like the exterior of a home. So opposite angles on the outside of the two lines that are intersected by the transversal. So now we're focusing on just the outside of the two lines for exterior. And then if they're alternate, same thing, that means like the opposite side of the transversal. So for these ones, our alternate exterior would be 2 and 8. So angle 2 and angle 8. And then the other pair, still same thing, just looking at the outside angles, but the other pair would be angle 1 and angle 7. So angle 1 and angle 7. So moving down to the next section, this part that's kind of snuck in here in italics, I haven't said that word out loud in a really long time, but the like sideways writing for the lack of a better term. Okay, anyways, the next part says when parallel lines are cut by a transversal, the corresponding alternate interior and alternate exterior angles are congruent angles. So that's a lot to dissect. We're just going to go ahead and read through the theorems that not justify that, but the rules that go along with that, because it at least kind of separates it by interior and exterior. Okay, so another set of rules, or a new set of rules to kind of add hopefully to that ongoing list of rules and postulates and theorems and all that stuff. So there's the corresponding angles postulate. So it reads, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So all the corresponding angles will be congruent. So like, for example, 1 is congruent to 5. Let's see, 4 is congruent to 8. All the corresponding angles would be congruent as long as the two lines are parallel though. So it's like N and M must be parallel for these to be true. If they're not parallel, it's not going to be true. That's kind of like the example we had up here. Oops, sorry. And then the second new theorem, so alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So alternate interior, so we could say like 4 and 6. Those are alternate interior, because like interior, we're just looking at the inside of the lines. So 4 and 6 would be congruent, and then 3 and 5 would be congruent, because they're on the inside, but they're on alternate sides of the transversal. That's the one that cuts like down the middle. Not down the middle, but through both. And then the next theorem, alternate exterior angles theorem. So if two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So it's the same theorem essentially, but it's just now we're looking at like the alternate angles only. So the alternate exterior angles are congruent as well. So in this case, it would be angle 1 and angle 7. So they're on the exterior of the two lines and they're on opposite sides of the transversal. And then the other pair that would be congruent would be angle 2 and angle 8. So same thing outside and then on opposite sides. So these, I know like all these theorems and kind of like the new definitions and stuff, they have a lot of similarities with the way that they're written and kind of their terminology. So it does kind of take a second to differentiate between like the different ones. These would be like really good things to put on a note card. I know like a lot of times in math, it's not super note card heavy, but these are good examples of things that we can put on note cards, and you can even draw a picture like this and maybe like highlight or like put the actual alternate interior, alternate exterior angles on there and label them. That'd be a really good way to help kind of memorize them. Okay, so now we're just going to look at it as a whole and list all of our corresponding angles, list all of our alternate interior and alternate exterior, and to state that they're congruent, because that's what we know now based on the rules. So we'll start with corresponding angles. So the first one I want to list, and it doesn't matter what order you go on, we just need to pick a pair of corresponding angles. I'm going to say angle 1 and angle 5. So I would write that as angle 1 is congruent, so the equal sign with a little squiggly on top, to angle 5. So that's one pair. And then another pair. So remember, corresponding angles, those are the ones like they're in the same kind of placement, but a different intersection. So if this is one intersection right here, and then this is the other right here, both of like angle 2 and angle 6 are in the upper right corner of that. So same placement, different intersection, those are corresponding. And this theorem or postulate says that they're congruent. So we would say angle 2 is congruent to angle 6. And then we just want to go through and list all of them. So angle 3 and angle 7, those are both at like the lower right hand corner of their intersection. So we can say angle 3 is congruent to angle 7. And then the last one, angle 4 and angle 8, are both at their like kind of lower left hand corner of their each, or like their personal intersection. So we could say angle 4 is congruent to angle 8. Okay, so we have 4 pairs of corresponding angles. We can move on to alternate interior angles, and then just keyword is interior. So we can take our focus and just look at the inside of the two lines. And then interior, or sorry, not interior, alternate means on like alternate or opposite sides of the transversal. So the first one I'll list is, say, angle 3 and angle 5. So this theorem says if two parallel lines are cut by a transversal, which is what is happening in this picture, the alternate interior angles are congruent. So we can say that angle 3 and angle 5, because they're alternate interior angles, they are congruent. So angle 3 is congruent to angle 5. And then the other pair of alternate interior is angle 4 and then angle 6. So they're interior, they're inside the two lines, they're on alternate sides of the transversal, so they are congruent. So we would say angle 4 is congruent to angle 6. And then the last one for alternate exterior angles, so exterior meaning like the outside of the two lines, so we're looking at this pair and then this pair, and then alternate, same meaning like on opposite sides of the transversal of line L. So first pair we could say is angle 1, and then alternate, so on opposite sides should be angle 7. So angle 1 is on the left side of the transversal, angle 7 is on the right side, so angle 1 is congruent to, oops, that squiggly is a little crazy. Oh, they're just getting worse. Okay, angle 1 is congruent to angle 7. And then I didn't read this one, but it's like really similar to the alternate interior theorem that we just kind of read through. But if two parallel lines are cut by a transversal, which is what we have right here again, then the alternate exterior angles are congruent. So that's why we can say angle 1 is congruent to angle 7. And then the other pair that we can look at of alternate exterior is 2 and then 8. So angle 2 is congruent to angle 8. And then we've covered all of them now. So like I said, really, really good thing to like maybe put on a note card, or even if you just have to cut up a piece of paper and kind of test yourself back and forth and make sure that you're able to identify like, okay, I know 3 and 5 are alternate interior, and I know that 1 and 7 are alternate exterior. Those are the kind of things that you would want to be able to recognize after some practice. Okay, so 12.2 is just more vocab. So starting at the top, it's supplementary angles and parallel lines. So same side interior angles. So two angles that are between the lines on the same side of the transversal. So interior means the same thing here, means we're just looking inside the two lines. So we're looking at like angle 3, 4, 5, 6. And then same side means same side of the transversal. So we're really just looking at either 4 and 5 or 3 and 6. So we can say angle 4 and angle 5, because those are both inside the two lines and they're on the same side of the transversal. Or the other pair would be angle 3 and angle 6. So interior inside the two lines and then on the same side of the transversal. And then for the next one, same side exterior angles, so two angles that are not in between the lines on the same side of the transversal. So for exterior, we're looking outside of the two lines. And then same side, they should be on the same side of the transversal. So one pair would be 1 and 8, so it's on the outside and they're both like kind of to the left of the transversal. So we would say angle 1 and angle 8. Or for the other side, it would be angle 2 and angle 7. So outside the two lines for exterior, and then on the same side because they're the same side. So angle 2 and angle 7. So fortunately, like the names of the kind of definitions or what we're defining match what we're looking at. It's just there's so many of them that it gets or it takes a while to get comfortable using all the different terms. So the next section, if the lines cut by a transversal are parallel lines, so kind of like what we had in 12.1, then the same side angle pairs are supplementary angles. So they're not congruent, but they're supplementary, which supplementary means that if you add them together, it equals 180 degrees. So supplementary means that they add to 180 degrees. Okay, so we have a couple new rules starting right here, and then we have our graphic that goes along with the like parallel lines with the transversal. So the first one, the same side interior angles theorem, I'm not going to point out the pairs yet because that's what we're going to do like down here in this section. So I'll just read through the rules at first. So same side interior theorems, or theorem, if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. And then for the second part, if same side, for same side and exterior angles, so it's like a tongue twister now. Same side exterior angles theorem. So if two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. So they're both supplementary, basically. Exterior and exterior, interior and interior. So first we'll list the same side interior angles, and just not that they're congruent like we did up here, but that they are supplementary. So they add up to 180 degrees. So for same side interior, we're only looking at the inside of the graphic. And then same side, so they need to be on the same side of the transversal. So 4 and 5. So we can say angle 4 and angle 5 are supplementary. And then for the other side of the transversal, it's 3 and 6. So we can say angle 3 and angle 6 are supplementary. I'm just going to use the little quotes just to mean the same thing. So angle 4 and angle 5 are supplementary. They add up to 180. Angle 3 and angle 6 are also supplementary. And then now we can move on to the same side exterior angles. So exterior means we're looking outside of the two lines. So for same side, it would be 1 and 8. So those are going to be supplementary. So angle 1 and angle 8 are supplementary. And then on the other side of the transversal, it would be angle 2 and angle 7. So angle 2 and angle 7 are also supplementary. So I know this is a lot of new vocab, but these do really come in handy, and they basically allow us to kind of figure out problems that are kind of puzzle-like. So for example, let's say I knew that this like first angle, like angle number 1 was, let's say, 70 degrees. I could find every other angle on there just by knowing that one angle. So just throughout all these theorems, and like, we know vertical angles, and we can kind of piece together the puzzle that way. I'll save those for once we actually get into those problems, but that's the purpose of learning all these new definitions and theorems now, so that we know which angles are the same, which angles are supplementary, and it allows us to find missing angles eventually. So 12.3 is proving lines are parallel. I'm going to save the proof for the live session, but we do have some new rules to go through. All these rules are converses, so you can see like converse, converse. That means it's the reverse of the original postulate or theorem that we learned about. And we've done a discussion post on this in the past where like a lot of times the converse doesn't really make sense, like when you switch around the order. In these cases, it does, and it helps us prove certain things. So like these could be just justifications or reasons that you use in future proofs. So first one is the converse of the corresponding angles postulate. So I just want to go back up to the corresponding angles postulate really quick. That was the first one we did. So it's up here. The corresponding angles postulate, it reads, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. The converse is going to switch the order around. So it's going to kind of start with the corresponding angles and then finish with the parallel lines. So right here, if two lines are cut by a transversal in such a way that a pair of corresponding angles are congruent, so it starts with those corresponding angles being congruent, then the two lines are parallel. It finishes with that. So with the figure picture, we have two lines, P and Q. We don't know if they're parallel. And then those two lines are cut by a transversal. So they're cut by T. And then when they're cut, there's a pair of corresponding angles that are created that are congruent. That would be angle 1 and angle 2. If we know that those two angles are congruent, then we also know that the two lines are parallel. Okay, so if angle 1 is congruent to angle 2, then line P is parallel to line Q. So just the reverse of the postula that we already kind of learned about, but it works both ways is the point. And sometimes depending on what information you're given, you'll have to use the original or the converse. So second one, converse of the alternate interior angles theorem. If two lines are cut by a transversal in such a way that a pair of alternate interior angles are congruent, then the two lines are parallel. So same thing, we're starting with two lines, they get cut by a transversal. That transversal creates alternate interior angles 1 and 2. If we know that those are congruent, then we also know that the two lines are parallel. So if angle 1 and 2 are congruent, then line P and line Q are parallel. The next one, so converse of the alternate exterior angles theorem. So if two lines are cut by a transversal in such a way that a pair of alternate exterior angles are congruent, then the two lines are parallel. Same thing, we have two lines, we don't know if they're parallel at first. They get cut by a transversal. That transversal creates alternate exterior angles 3 and 4. If we know that those two are congruent, then we also know that line P and line Q are parallel. They go hand in hand. The next one, converse of the same side interior angles. Remember for same side interior angles, like 1 and 2, for example, those were supplementary. They were not congruent, so keep that in mind. So if two lines are cut by a transversal in such a way that a pair of same side interior angles are supplementary, then the two lines are parallel. So same thing, start with our two lines. We don't know if they're parallel. They're cut by a transversal. That creates the same side interior angles that we know are supplementary. Like that would be information that's given to us. If we know they're supplementary, then we also know that line P and line Q are parallel to each other. And then the next one, converse the same side exterior angles theorem. So remember exterior angles, those were supplementary also if the two lines were parallel. So if two lines are cut by a transversal in such a way that a pair of same side exterior angles are supplementary, then the two lines are parallel. So same idea, start with our two lines. We don't know if they're parallel. They get cut by a transversal, creating the same side exterior angles 3 and 4. If we know that they're supplementary, then we also know that P and Q are parallel to each other. Okay, so just the important thing is to know that those two things go together. If, let's say, like, there's same side exterior angles are supplementary, they have to be parallel. Same side interior angles are supplementary, the lines have to be parallel, and so on. So the purpose is just to show that, like, these theorems go, like, one way, and then they also are true if we say them in reverse, which is not always the case. And then we're going to stop there. Like I said, we're not going to do this proof. We'll save it for, or we'll do a different one in the live session. Like I said before, and I just want to reiterate it, this is a lot of like pretty wordy, like new theorems and new definitions. It's a really good opportunity to kind of make some note cards, make sure that you're really understanding each definition because there's a lot of them and they all sound so similar that at times it can be hard to like tell the difference between them.